Welcome to Cookie's Maths and Science Hub. In today's video, we're going to be exploring covalent bonding. Before we get into some specifics about bonding, let's remind ourselves about valence electrons. Valence electrons, or that is the electrons in the outermost shell of an atom, are essential for bonding. And we can determine the number of valence electrons of an element by looking at the Roman numeral on our periodic table, as the number of valence electrons of an element is equal to this number. Now, elements want to have a full outer shell. That is the core concept of bonding, whichever type of bonding we're looking at. So keep that in mind as we start to talk about these bonds moving forward. Covalent bonding involves the sharing of electrons between two atoms. So whereas ionic is the transfer, covalent is the sharing. Atoms share electrons, once again, to achieve that stable electron configuration and form molecules. This occurs between non-metal atoms, allowing them to achieve a full outer electron shell through their shared electrons. So if we look at fluorine as another example, you can see it has 7 valence electrons. So if 2 of them come together, they can share an electron each to form a full shell for each of them. And you can see now they're sharing 2 electrons between them, making each of them have a full outer shell. Covalent structures can be split into 2 distinct groups: covalent molecular structures and covalent network structures. Covalent molecular structures are compounds containing molecules with covalent bonds, whereas network structures are a large network structure, as the name would suggest, where the bonds between atoms go throughout the entire material and are very strong. In most cases, there are some unique cases. For covalent molecular structures, they're often gases or liquids due to their relatively low melting and boiling points, whereas covalent network structures have incredibly high melting and boiling points due to their strong covalent bonds in those extensive networks, so they're usually solid and can be extremely hard. Neither of the covalent structures are very good conductors of electricity, and often, most of the time, they are insoluble in a lot of different liquids. Writing the formula for the provided names. Okay, let's go through the answers for these ones. So we have NO2. So we know our first one is going to be nitrogen because that's the furthest left on the periodic table. And we have 2 oxygens, so it's going to be dioxide. Then we have CO2. Realistically, you've probably seen this one many a times in your science studies. It's carbon dioxide because carbon is the furthest left. And then there are 2 oxygens, so dioxide. We then have CCl4. So again, we know our first one's going to be carbon. And then we have chlorine, or it'll become chloride, and there's 4 of them, so that's tetrachloride. Then, looking at writing out our formulas for these named ones, we have dinitrogen monoxide, so that means we're going to have 2 nitrogens followed by 1 oxygen, so N2O. Then we have sulfur trifluoride, so we're going to have 1 sulfur, because we don't need to include the mono if it's the first one, remember? And then we're going to have 3 fluoride, so SF3. When it comes to naming covalent structures, there are 4 simple rules, much like ionic. We name the non-metal furthest to the left on the periodic table by its element name, and we name the other non-metal by its element name, and once again, change it to an "-ide" ending. We need to make sure we use the prefixes in these cases. So if there's more than 1 atom of an element present, we have to say di, tri, tetra, etc. to indicate the number of that element. If mono is the first prefix, it is understood and not written. So we don't have to write mono if it's, something like CO2, which gives us the first carbon. We don't need to write mono for that one, it's just carbon dioxide. Now, let's look at some examples there. It looks like I've just given you the answer for one, but pause the video and have a go at naming some of these structures. Now again, it might seem like a lot to remember for these ones. However, it's important to realize that all this information, such as the prefix names that you can use, are on your formula sheet, or at least they should be for any test you are completing. Thanks for watching. Hopefully now you have some foundational understanding around what covalent bonds are and how to name some basic structures. Be sure to leave a like and comment for future topics you'd like to see explored. Please subscribe to the channel, and we hope to see you back again soon.